Hi. Hello. Hi. It's on the thing. It's so exciting. So I'm going to put this on YouTube for the Berlin team, as well as anybody else who would like to know about DDD and about Imagine Easy. So I'll be speaking to that audience a little bit as well. So that's why I'm the first person on here, because I'm Cameron Edwards, and I work at Imagine Easy Solutions, which is awesome. Yeah, so we make EasyBib and a lot of other educational resources. So today we're going to be talking a little bit about domain-driven design. We're going to go kind of in sections, and if you have questions at the end of a section, then we can talk about them. And then at the end, I would like to really talk about how this can apply to our next big project, which is Scholar. So I first got introduced to domain-driven design 1 year ago when I started working at a little startup called Daily Goods. And it was a family company, so I got a job there as a front-end developer because I don't think anybody else ever would have hired me. I had never taken a class in programming, but I knew a little bit of JavaScript, and so my dad was like, you should probably just do our front end because you don't really have to know that much to do that, which was totally wrong, it turned out, and a huge mistake. But I was doing that, and so my first day on the job, I was really chomping at the bit to start coding and to get my first coding assignment. And so he was like, all right, well, we're going to have a 1 hour planning session before we get started. And I was like, oh, all right, I really want to start coding, but that's okay. The 1 hour planning session turned into 1 week of domain-driven design sessions and modeling sessions. And for the first day, I was just going out of my mind. I just really wanted to get my hands on the keyboard. But throughout the rest of that week, I just became totally sold on this concept. And it has really improved my life, not just in my career, but in many other aspects. So that's why I say it's better living through software modeling. And this is the world's creepiest cat gif, just to say, let's get started. So one of the main premises of domain-driven design is that the job of software is to solve a problem or problems having to do with a particular domain. So what is a domain? A domain is just an area of expertise of some kind. So it can be an industry field, it can be something like banking or accounting, or it could also just be an area of interest like penguins or marine biology or something like that. So some of the different domains that different applications are seeking to solve. OkCupid is trying to solve the domain of matchmaking. Facebook is trying to solve the domain of social networking. Vantage is trying to solve the domain of ad optimization. Sumall is trying to solve data analysis. Photoshop is a really great app that's trying to fix problems in the area of graphic design. GetCourse is trying to solve teaching. And EasyBib is focused on the domain of academic research. So successful software starts with focusing on the domain and really trying to understand it. But that's kind of a vague idea, I think. Focus on the domain. What does that really mean? So the first thing that you need to do in order to focus on the domain is you need to start seeking understanding from domain experts, because they know more than you do. If you want to build a banking application, then there is no way that you can really do that effectively without understanding something about banking first. So domain experts are also sometimes business stakeholders or product owners. Sometimes they're invested in the product that you're making. Sometimes they're not. The point is they just know a lot about what you're doing that you don't. So you first have to ask yourself, who is an expert in your domain? So in the domain of matchmaking, if I were going to make a competitor for OkCupid, then I would probably ask I don't know how to pronounce that, but I guess in some areas of Orthodox Judaism, they have these matchmakers who their job is to match people up. So I'd probably learn from them what a good algorithm would be for matching people.
No.
No? We can have a lesson about that afterwards. If I wanted to learn about social networking and I wanted to build the next Facebook, I would probably ask Neil Taparia, because he knows a lot about that. If I were to build ad optimization software, I would ask Emery Downinghall, because that's what he studies all day long. If I were to go into data analysis, I would ask a statistician to teach me how statistics works. If I were to make the next Photoshop, I would probably want to get the input of a designer. And if I were going to go into teaching, then I'd ask Jack Black. Just kidding. Maria Montessori, who's the founder of the Montessori school movement. And if I were to study, if I wanted to make the next easy bib, then I would probably ask Alison Cloyd, because that's what she studied in college. So, so the next step to making good software is to create a model based on this information that you've gotten from your domain expert, and you can use that model to help your software develop. So you have to ask yourself the question, what is a model exactly? It's another one of these kind of vague terms. A model is a blueprint of the domain that exists inside the mind of the developer. So a model basically is a way of a domain expert who speaks in terms of business jargon, and a developer who thinks in binary code, apparently, to be able to find some common language that they can use. So it's some common ground between the business and the developer. So here are some common misconceptions that developers tend to have about the model and what that is. The model is not source code. So you have code that reflects the model, and you have some words that are in your code that are words that also exist in the model. But code is just an implementation of the model. The actual model exists in your brain and in the brains of your team members. The model is not the database. It is not data. Some of the data associated with the model is stored in the database, but the database is just another implementation of the model. The model encompasses domain logic and data and objects, and it exists in the mind of the developer. And the model is not a diagram. A diagram is just a way of showing what the model looks like. Okay, so some perks of using a model, and this might seem like a vague concept. Allison and I are going to go through a way that you can actually kind of start to visualize what a model might look like. But some of the perks of using a model. I think we've all been in a situation, in a meeting, where somebody's talking about parsers or databases or queries or something like that, and we have no idea what they're talking about. I find myself in that situation all the time. So the model is what we call ubiquitous language. We are all talking about the same objects. And so you kind of nail down what some consistent terms are that you can use to address things, and you start speaking in terms of business objects. Another perk to domain-driven design and using models is that it helps you to handle complexity. Yitz introduced me to this graphic. A lot of the time, as developers, we look at something, we're like, I'm starting an application, this time I'm going to do everything right, and like a month later your code is a completely unmanageable mess. And you're like, how could this possibly have happened? And I think it's because complexity is sometimes just built into the domain. The domain's just complex, and if you don't have the tools to approach that kind of complexity, then things are going to get out of hand pretty quickly. This is another example of things kind of going to pot pretty quickly, I think. You're like, what have I done? I don't even understand what this graphic means. I just think it's hilarious.
There's context for this. I don't know what it is.
Yeah, this is not the context for this graphic. I don't know. It seemed appropriate. So the other thing is knowledge sharing. I think it's impractical for me to try and become an expert in design, or try to become an expert in everything to do with research, or to become an expert in everything to do with relational databases or PHP. And in the same token, not everybody on the team can understand what everybody else understands, but everybody on the team can understand the model and can get more familiar with it and speak in terms of the model. You can read that one later. It's pretty funny. So I bring up this image, the Vulcan mind meld, because that is what it means to have one concept existing in the mind of more than one person. So the model should be in everybody's minds. We're about to do it. So the question becomes, how do I translate a domain expert's knowledge that they've given me into a model? So Allison and I are going to kind of role play a way that this might happen. But first, do we have any questions? We've kind of gone through a lot already. No?
Oh, I do have a question.
Okay.
So you said that the model doesn't, like it's, so I understand it's not code and it's not the diagram, but it has to be something that has to exist somewhere. You said it exists in the mind of, so what is it like? Is there any canonical representation that you can say, okay, this is the model? Because in your mind, like, there's no way to, like, express that. That's electrical current moving through your body, right? So, like, would you say there is, or there isn't? There just is not?
There is no canonical source for
Okay.
the model. We're going to kind of hopefully get a little bit closer to what that means as we go along here. But so I'd just like to walk through an example here where I had Allison pretend like she wanted me to build an application that helps students use the Cornell note-taking system. And I don't know anything about the Cornell note-taking system. So this is a good example of a time when a domain expert knows a lot about something and the developer knows nothing. And you have to find some common ground. So we're just going to kind of read through this, and I'll be doing a lot of drawing. So,
Okay.
Do you want to get started?
Sure. So I'd like you to build an application for me that makes it easy for students to use the Cornell note-taking system.
Okay, so what is this application supposed to do? I guess you have to explain the Cornell note-taking system to me.
So it is a very specific style of taking notes, which covers a broad point or many broad points of a lecture or maybe a book. Whatever subject the student is pulling information from, they need to be able to enter very specific big points. From that, they then need to be able to pull cues, like very small sentence summaries or very brief points or maybe even just one word. And then there needs to be a way for them to see their cues, which should be next to their broad points, without seeing the broad points, so that by looking at their cues, they're forced to remember what those cues mean. And then underneath the cues and the broad points, there should be a space where they can write a summary of all the information they've gathered, or the goals for what they want to get out of the lecture or the book, or whatever it is that they're taking notes from. And then they use the whole thing to review for a test or a quiz or a paper.
Okay, cool. That was a lot of information. Could you walk me through the setup a little bit?
So there's a specific setup for this, which is 2 columns, a skinny column on the left for the cues and a big one on the right for the broad points. And then, so they would write their broad points in first on the right, then their cues on the left, and then the bottom section underneath both columns where they write their summary. And at some point they need to be able to cover up the broad points to see only the cues, or possibly both the broad points and the summary, to only see the cues so that they can practice what they're supposed to be learning.
Okay, cool. So the layout of the page looks like that?
Yes.
About? Okay, cool. So that was a lot of information. Let's start over. It sounds like we have some objects that we're dealing with right off the bat. It's going to be hard to read and write at the same time. So you mentioned big points. I'm going to call it big point because that's easier to write than broad point. And cue. So these boxes in this diagram mean an object of some kind. Okay, cool. So we have a big point, we have a cue, and we also have a column and a summary. So can there be more than one cue for a single big point?
Probably not. There should be really only one cue. So when you cover up the big points, you can look at the cue and figure out what it means in a broader or wider context. So if you're listening to a lecture on dogs, and one of the points is that there are many, many breeds of dogs, you would write that down in your big point, but your cue would maybe only be hundreds, because the idea is to condense your big point as much as possible. Or, you know, there are hundreds of breeds, or maybe your cue is many, so you're setting up the system of cues with memorization, so that when you write the summary, you can bring it all together to synthesize all of your cues and big points into one big picture.
Okay, so we don't need to provide people with the ability to make more than one queue for a single big point, so you only get one queue?
The queue could be a sentence or a question. So it could be one item, but not necessarily one word, but it shouldn't be more than one. Because if you would need multiple queues, then it's probably multiple points, or just like you need to be able to pull it into one sentence.
Okay, so this means that it's a one-to-one relationship, and each big point has a queue. Is that right?
Yes.
Cool. And I'm also going to say that this has text. The queue is basically just text, right?
Yeah.
And this also has full text.
What's full text?
So full text in this context would be like a longer sentence about dogs, whereas the queue would just be the word hundreds. Is that right?
Yeah.
Okay, awesome. So I'm wondering if a queue is really an entity in its own right, or if it's just a piece of text that actually belongs to the big point. So this right here, this means that queues belong to big points. That's what that diagram line means. So each big point has text that's going to be displayed, like the full text of the idea. And
each big point is just a bullet point.
okay, cool. So I think that a queue is just a string. So I'm going to move queue over here. And a column is going to contain these big points. And it's going to contain a lot of big points. Okay, so that's what that star means, that there are lots of big points for each column. So the column is either going to display a queue or the full text, but it's going to display something to do with the big point. So I think the summary is just a string. It's just text. So we put that here. Okay, so the summary is just a string. Do we need the ability in the summary to highlight like a piece of that text and tie it back to a big point?
The summary should really be their original thoughts in words. So the point of the summary is to see if they were listening. It shouldn't really have any copied text in it. It should just be all original.
Okay, so the summary is just free text.
Yeah.
So this is going to be a lot simpler than I thought. Does this look about right so far? A summary contains text, a column contains big points, and a big point a column might either display a queue or the full text of the big point, depending on where it's positioned.
When you do it on paper, it's 2 columns, because queues and big points need to be their own so that you can cover up one column and see the other. Like to be able to cover up big points but to see queues at the same time, if that makes sense.
Okay, yeah, so queues and big points have their own separate columns. So I'm also thinking there are 2 other really big objects that we're dealing with here. We have project, I think. Do you think that we would call it a project, the thing that we're working on?
It's probably more like lesson or topic, because you could, in theory, do Cornell notes for many different things all at once. Like if you were reading a chapter of a book, for example.
Okay, so this whole thing is one topic. What if we went to multiple classes on the same topic?
Then it would be different. Like if I had 3 classes where I was doing Cornell notes for each one, I'd have 3 sets of notes, 1 for each class.
Okay, so I think note set is probably the best descriptor for this object. So a note set is going to be the thing that actually contains the big points. It contains lots of them. It also contains 2 columns. Oh, that's not good. It contains 2 columns for each one note set. And the columns also contain big points, but the fact that this is an open diamond means that that's like a loose relationship. Like the columns don't actually own the big points, they just display them. And the note set also contains 1 summary. Okay, we also have one other thing, which is our user, which is going to have more than 1 note set. So this user is probably going to have a name. Do we need to know anything else about them, like their school or anything?
No, because it should really be only individual use. Like this isn't going to be a group project or anything.
Okay, great. So it's individual use. It sounds like it depends on the user to set up the application. So it looks like this ended up actually being a pretty simple model for us to start working with, to maybe build some use cases on. Does that kind of make sense how that process might work a little bit? That I start to extract some knowledge?
Yeah. I mean, the only thing that I would ask about is here it seems like conceptually the model is the Cornell note-taking system, right? That's already been devised by someone else. But let's say, for instance, you were creating a bartering application. There's no, let's say you wanted to create your own bartering model. You have to start a step back from where we are here and devise the model. So are you going to be going into detail about that, or are we just starting from the point where you have a conceptual model?
Well, essentially what you're saying is sometimes you have to develop your own conceptual model before you can't just extract it from somewhere. And that totally makes sense. I wouldn't want to reinvent the wheel, but if I have an application that does something that's never ever been done before in the real world, that's going to be a step you have to take.
In terms of like these items like big point, note set, summary, are these the words that then the team uses in their shared language?
Yeah, so you might say I'm working on the page where you create a note set, rather than I'm trying to implement some view with some kind of arbitrary name. You're going to refer to the note set creation page. Any other questions up to this point? Okay, cool. So what we just kind of went through is Allison and I shared some verbal communication. We just kind of talked things through, and this is sort of a messy process. They say that software design is an art, it's not a science. So it's going to just kind of take some feeling out to get to that point. We also did some diagramming, which helped us to create a picture of the model that's going to be in our minds. And at the end of this meeting, we're going to go through some use cases and kind of show how that can be really helpful in developing this as well. So up to this point, I think everybody should sort of be able to understand what's going on. This is a little bit more developer-centric, this part, but just hang in there with me for a little bit. So in order to make models, you have to know what models are made of. You have to have some building blocks to start working with. So the first and I think the most fundamental building block of a model is your entity. So an entity is something with a unique and persistent identity. So just like there can never be a copy of Cameron that's made, you can never copy an entity. So in that sense, each one is unique. And it also persists beyond the lifetime of the application, so I can shut down my computer or I can exit out of the application and it will still be there when I come back. So we are going to track this identity and make sure that each one is unique by using a key or a combination of properties of some kind. So some examples of how this might work. For a user, you have an email as their identifier key that makes them unique. And no two users can have the same email. With a bank account, you can imagine how catastrophic it would be if two accounts had the same number, or if you weren't able to tell the difference between the two. So each one has an account number that they use to identify it, which is unique. Something like a shipping route probably has an arbitrary ID, like it might just be a random number or a timestamp or a GUID or something like that. And a book might have an ISBN that you use to keep track of the identity of that book. So we have entities, we also have value objects. Value objects are objects that have values, but they don't really have identities. Their identity isn't important. So they're properties of entities and they are immutable. So you should really only change a value object by completely replacing it. We can talk a little bit more about that. It's not as important of a point, but this would be a good example of how a value object interacts with an identity, or with an entity. The user would be the entity in this case, and name would be the value object. So somebody else in my system could also be named Cameron Pratt Edwards, and they could have this same object, but the user is still unique, and the name, it doesn't really matter if it's unique. Cool, so then we have factories. Factories are a pretty basic design principle, but they become a lot more important when you're talking about modeling. So the job of a factory is to make entities for you. So let's take the example of software that's built for printer manufacturing, for example. A printer might not the job of a printer is to put ink onto paper, right? And you have all these different pieces that go into the printer. The printer's job is not to like screw its own screws into itself and like load itself with paper and put cartridges in. That's the job of the factory. So you're going to create a printer factory to create the printers. So instead of loading a bunch of logic into your entity constructor, you want to turn to a factory for most of those things. Then you have services. So the services are the verbs of the application. Sometimes you have a job that needs to be done. Like you might find yourself using words like user manager or something like that. So you have a job that needs to be done, and so you just kind of can throw those jobs to be done into a service rather than putting into some entity where it really doesn't belong. So a good example in EasyBib is maybe you need to take the title of a book, stick it into some kind of method, and get out a formatted citation. So this is what that process might look like. You would create a citation service object, and you would give it a format book method. So you give it a title, and the citation service is going to do a lot of different, really messy stuff here. It's going to call the WorldCat API to get some publisher information. It's going to pass that information into a book factory to get a book out. And then it's going to put the book into a book repository after it gets out of the factory so that it can store some analytical information about it. And then finally, it's going to pass it into a view, which is going to parse it into a string, and then it's going to return that string to the user. So there's not really just one, not just one thing or like a really centralized place where you could put all this logic, so you can put it into a service. And then you have repositories, which are part of your persistence layer. They're basically a bucket for data. So you could take something like a book, and you could dump it into a bucket, and then you can come and get it out of the bucket again later. Or you can take it out of the bucket and you can change it a little bit and then put it back into the bucket again, and those changes will be persisted. Or if you want to delete it, you can just take it out of the bucket and throw it away. So some of the benefits of using a repository, I know that especially with EasyBib Scholar, we want the logic to be really separated from the implementation. We don't want to be tied down to a particular kind of database or something. So a repository is an interface, so you can read and write data using a repository without really knowing where that data is coming from or where it's going. And so it might be talking to a REST API or WebSockets or a relational database or Mongo. It might just be storing it in memory in the case of like a test mocking repository or something. But it doesn't really matter. You don't have to worry about it. So that's why it's called the database abstraction layer. It just allows you to think less about those things. So those are some of the building blocks. Any questions about entities, view models? Sorry.
Yeah.
Value objects.
So in a lot of instances, there are frameworks and they have like a, say, ORM, and that sort of acts as the database abstraction layer. But like, let's say in the case of Scholar, who's writing the database abstraction layer? Who, when it's like, oh, .save, who's writing the logic that says, okay, well, if it's this kind of database, do this. If it's that kind of database, do that. Where does that come from?
You would have to write your own repository depending on what you need. So you might be able to use a repository just out of the box if it lines up with that interface.
Writing your repository interface for the application and translate that to implement it with some kind of out-of-the-box solution. Like some existing ORM or whatever. But the idea is that within the application there's some interface that all various repositories speak.
Yeah.
So testing repo has the same interface as the production ones.
Yeah. Does that kind of make sense?
Yeah.
So you might have to roll your own repository. Yeah. Sorry, John.
How is it that different than a database? Or repository versus a database?
Because a repository accepts entity objects and a database accepts queries. So a repository, I can say, here's a book object, here you go, repository. And then the repository is going to do all the messy stuff of parsing that into a query and turning it into something that a database can speak and store. So that I don't have to worry about it. The repository takes care of all that. Does that answer that question? If it can be reused across all kinds of persistence methods, all kinds of domain types, then it really belongs in the infrastructure layer. Just a handful of rules for layered architecture from Professor Black. Information is going to flow one way, and that is up. And the way that we achieve that is just going to draw out our layers here. Systems and infrastructure. So in each of these layers, we have all kinds of different objects. These little squares are objects. So a given object in a layer can talk to any other object that's in the same layer that it's in, and it can also talk to any objects in any layer below it. The one, and this is true of all of them. You can talk to that guy, and you can talk to that guy, and that guy. The one thing that you can't do, with one exception, is this. You can't have an object in the domain layer contain a reference to an object in the application layer, or have an object in the infrastructure layer contain a reference to an object in the persistence layer. And that's just because if the domain depends on the application, it's no longer the domain. It's no longer reusable. You can only use it in that application. And the same is true down the line. The one exception is in the persistence layer, you are going to have to contain a reference to entities, because that's just kind of how persistence layers work. But this also helps us with a lot of problems like dependency management. This makes it so you won't ever have circular dependencies if things are always pointing in one direction.
Can you provide a brief example of where you, might shoot yourself in the foot if you, like a concrete example using actual tech?
Yeah. So with this JavaScript framework that I'm building right now, I was building out a templating engine. And so I wanted to just make it like an augmented version of the DOM, essentially. Actually, that might not be the greatest example. I'm going to have to think of a better example for you of how that might happen. I think this is pretty intuitive once you kind of acknowledge it's how it works.
If anyone else didn't, then it might clarify.
Maybe just when you update a certain type of entity, there being some reference in there like turning blue on the screen, or what do I know about a screen in the
Yeah. Yeah, that would be a good example of how that works. So that is references. So let's just get a little bit of practice. It's really hot in here, and it feels a little bit sleepy. But I'd like to start getting everybody involved. Okay. So let's just go through a use case. We talked about use cases being a good way of fleshing out what your model is. So Katie and Molly have been kind enough to give us some great use cases. Some user stories is a better word for it. So I'd like to just go through the process of teacher sign up and talk about what that means in terms of our model, and just go from one interaction, which is the teacher clicking on the submit button, all the way from the UI down to the database and back. And that'll kind of give us a picture of what objects we're going to be dealing with.
Could you make it way bigger?
Yeah.
Thank you. Yeah.
There we go.
That's the stuff.
Okay. So I'm going to hopefully not be doing a lot of talking through this, but we just have to kind of go through the steps that Katie's already outlined. So the first thing is the teacher access easybibscholar.com or whatever it is. So the teacher signs up by essentially, so we're going to say they type in their first name, last name, email address, password. They've clicked submit to go to another screen, and their passwords are validated against each other. At which point they are brought to a new page with additional fields, and they type in their school name, district name, state, and subject and grade, and then click submit. and it's that submit click that I'm interested in. So we're going to call this use case teacher clicks submit. So what's our first step that needs to happen in order for this teacher's information to get saved? What needs to happen programmatically in order for this teacher's information to get saved?
We need to retrieve the form data from the page.
Retrieve the form data from the page.
So are you assuming, like, what level of granularity are you?
The most granular level. So I'm talking like, we want to basically build out a stack trace.
Is this like part of the model discovery?
Mm-hmm.
Okay. How come, like, so in this case, earlier we did the verbal communication part of it, and then is this another angle perspective of it, or is this like the next level that you have to go into?
It's part of the same process,
Okay.
I would say. Helps you to flesh out the model.
Okay.
I'm going to say that we have done a little bit of discovery already. We know a little bit about our domain. We know there's a teacher object, a teacher entity. And that teacher is a user, right? So Casey, you said we need to get data out of the form, sorry.
Yeah, I mean, that seems like a place start.
Okay, how are we going to get data out of the form?
I mean, there are a variety of ways you can do it, but let's assume, without getting too specific, that we're identifying the form by its name, and we're just grabbing each value by its name. I don't want to get too specific. I don't know if you could guide me as to
Okay.
how specific.
We have a couple of tools that we can use. We got data binding. And we have model view controller. So I think it would be really good if just throughout this process, so we already have a model on the page. Can we perhaps say that? That there's a model in memory of a teacher, and as the teacher has been writing in their information, that model has been updating with each click. Does that work?
Yeah, I guess so.
Okay. Prem, you looked like you had something to say.
Yeah, just to, for extraction, to get data from, if we're using MVC, I was just saying to host the form to a controller action where you can access the data.
Okay. Do we want to do a full page reload when this happens, or do we want this to be a single page application where they can seamlessly move on to the next page without a reload?
Single page application, of course.
Okay.
And then some Ajax would obviously be involved in,
So there's going to be Ajax involved.
yeah, if we want to do it, not the fancy way, the modern way, let's say. Want to do it the modern way, we would retrieve that information from the form and submit it to the server via Ajax. We might be submitting some JSON data, we might be, I mean, it varies, right? Like, we don't necessarily.
Okay. Okay, let's get specific. I would say we probably have a teacher view model that we're dealing with. The teacher view model contains a teacher entity. And I don't know how familiar we are with the concept of view models and entities. But a view model isn't actually data that gets persisted. It just kind of reflects data that gets persisted. So this model has been getting updated this whole time. And this model contains things like their name, district. Their grade level. Their password. And their email. Kate, does that sound like information like that we want to store? Does that sound pretty comprehensive? Okay. So without, I guess, not going into too much detail of what happens before this, but with each keystroke, this model has been updating in memory. There's a teacher object that's been updating. And so we need to have something that's going to listen to the click event that they click submit and is going to know what to do about it. So perhaps we have a UI controller that does that. Feel okay about that?
Yes.
Okay. The click method gets called on the UI controller.
So, yeah, my question here is, this seems to be more like the application design itself. This is like discovering like a shared knowledge, a shared vocabulary around like what the application is. How are the two related? I mean, I know how they're related, but like how important is this in terms of building out the understanding of the model?
I think we have to get a little bit deeper, and we're just going to start to see the model kind of reveal itself as we go. Okay, I'm just going to plow through some of this stuff because I think that some of this might be my expertise, so maybe it's a little bit unfair for me to kind of stall on it. But what the UI controller is going to do is it's going to add, so the UI controller, let's call it a teacher controller. It has a model. It's called teacher. Yeah. So add teacher to teacher repository.
So is that the step in which you're recognizing it as something different from, say, a student?
We already know that it's something different from a student because they're on the teacher sign up page, right?
Okay.
So there's already been a lot that's gone on up to this point.
Okay.
So that controller is going to call teacher repository.save.
Okay.
And then the teacher repository.save is going to bundle it up into some kind of AJAX call and send it to the server. Is that fair enough? Okay. Bundle as JSON. Send to server. Okay, then what? What happens on the server? Sorry?
Why do we care from our point of view? I mean, like, what's the overall, I mean, here we're in our UI land, so we know we were sending something off someplace. So are we switching perspectives now? It's like,
Yeah, because the UI doesn't know what the server is doing, but the developer has to.
what people are supposed to do.
A developer has to. You're our server guy, it's one of them. What does the UI do with this JSON data?
Well, I mean, you're saying a finished application?
In a finished application.
Or there'd be validation then?
Okay, how does it get to the point of validation?
Well, let's say we've got a framework like Silex that is responding to these requests. So we have some sort of validation object that, well, first of all, we have a layer that takes the request data from the actual HTTP requests and packages it up.
What do we want to call that? The object that takes the request data? Can't do it.
Well, in one sense, it says like a model, my empty factory, but it's, you have a specific duty of taking the
want to just do one, just so we can see it? Because I'm still unclear as to because I get your earlier example about the kernel note taking system. I get how that will help everyone understand each other together.
Mm-hmm.
I'm just not clear how, because especially this is not something where non-devs can participate in.
Yeah.
I'm still unclear about how this helps us understand the model. But do you want to go through a couple, or want to do this use case?
Yeah.
So we can see how it fleshes out.
Well, I guess part of this is that we don't completely understand what the model is or what all the use cases are, and so it is kind of a discovery process. I don't know if maybe at this point, maybe just some of the devs can stick around, maybe just some of the Scholar devs.
Would you
Go through that.
have this conversation with like your domain expert, like when they're in the room?
I think it's good to have a domain expert in the room because we're going to start to.
And does the domain expert need to get to like, oh, I don't know what JSON is. Please tell me, is the domain expert what JSON is, or what an MVC is? Do you expect them to come up to that technical level in order to be a good domain expert, or at that point in time do they kind of turn off until you kind of work out the MVC code?
They kind of turn off some things that aren't going to be as much of something that they can participate in the process with, but we are going to be making modifications to our core entities, and that's where
It should be there to validate or.
Right. So yeah, maybe I guess we should just let go everybody except maybe the Scholar devs, and we could just push through this a little bit more. Would that be? It's kind of up to you. It's your time.
Well, I think the goal is to walk away with understanding how the process works.
Uh-huh.
Not necessarily to flesh out one use case, but just to understand where that's kind of driving the model.
Yeah.
So like if we were to just kind of come up with any example to take it through the end, you could kind of tell us how we're kind of feeding stuff into that model and say, yeah, you know what, that was a really efficient way of getting at the model. Or it might be like, wow, that's a lot of work to get to the model. Couldn't we have done it better or a different way?
Mm-hmm. Yeah. So maybe I think we've.
No, let's make assumptions all the way through this. We get through one use case.
Okay.
Let's just do this instead of us really going through the discovery process itself. Let's just make you can make some assumptions on what we need to do.
Okay.
Just so we can understand, how this can help us understand the model.
Okay. So the router intercepts the request. We have a router object. We just drew down here. And sends it to teacher controller. And the teacher controller has a method called a register that returns a view. Okay, so the teacher controller then calls teacher service dot create teacher and it's going to pass in the JSON data. Teacher service is then going to call teacher. It's 4 o'clock, guys. Teacher service is then going to call teacher factory dot from JSON. Passing the JSON data that's received. Teacher Factory's job is pretty straightforward. Basically just new teacher, and then it extends that teacher's properties using the JSON controller, using the JSON data. So the new teacher, we get a new teacher out of the teacher factory, so we're back to the teacher service. The teacher service then calls teacher repo, another object here, teacher repo. it has two methods. It's got add teacher and save teacher. Dot save, or sorry, dot add teacher, and then save it. And then the teacher service calls set cookie on the request object that it gets out of memory. And the teacher controller passes the teacher object that gets returned from the service into a view. The view is stupid and it just does whatever it wants to, and then it returns the view to the user. Actually, it's just going to return a JSON object. That at least goes all the way down to the bottom of the server. So I think this is a good example of perhaps something that would be best just for a couple of devs to do on a more granular level. So maybe this example wasn't the best one.
Go ahead.
And there's a response code here, right? And if you were building this for a mobile device, it's like this is sort of specific to a browser, right? Like that little part where you're like set cookie, that doesn't necessarily happen if you're building a native app, right? I mean, it may or may not, right?
Yeah, well, we'd have to set up another use case if we were doing it with a mobile app.
So the model doesn't change based on whether we're building a web app or a mobile app. So why would one more than another, or in concert with another, be needed in order to help come to a definition of the model?
I think that just this kind of deep diving in one form or another, you're never going to go through every single use case, but going through some of the use cases in the system is going to help you realize that there are not objects that need to be there. But
it doesn't have to be related to this project. An example of that you run across is I still don't. When you switch gears from the part of the talk at the beginning, which is the abstraction of this part, that's where it kind of there's a cliff for me.
Yeah. So I guess what the function of this kind of exercise would be is that what your question
just an
is?
example of where you use a password and helps you understand the model better.
Okay. So I guess going back to this JavaScript framework that I built, the domain in this particular case is the DOM, and I'm luckily a domain expert in that area because I just mess around with the DOM all day. And so I knew that what I needed to do was to say compile with a particular string. I wanted some function where I could pass a string into some kind of compiler function and a model into that compiler function as well, and it would return to me a little chunk of DOM stuff. And so what I did is I just said, okay, so I say compile with the string of this model, and then the compiler function spins up a DOM node that's kind of an expanded version of a regular DOM node. And it helps me to outline what all the different types of DOM nodes are, the control flows, and things like that. And that's really how I built my entire model that way. So that might not be that. That's a lot of really tech talk.
I mean, I guess it boils down to I don't understand why we need to know any of this in order to define a model. The model is really put the name right, and this is all implementation. So why do we need this in terms of that?
Perhaps if we talked about the example of the assignment. So say a teacher creates an assignment. A teacher pushes submit on a create assignment page. If we say what happens then, do we know what the properties are on that assignment object? What does an assignment contain? What does it mean to save an assignment? Does it mean that it gets persisted to a bunch of students, or Does it just go into a database? I guess that would help us to flesh out what the properties are on the assignment object.
So that stuff is true. Like, we need to figure out those details because save, generally speaking, doesn't mean much. It can mean lots of different things. Does it mean that we have to say save as in, like, you know, run the add method then the .save method, or is it more like we have to get our user stories to a level of depth where that granularity is visible or made explicit, like versus having it translated into code? Because I guess when we're talking about a shared model, you said every developer has a model in their head, which I guess this makes more sense in that context, but from the sense of being able to communicate with non-developers, this is like,
yeah,
right. So is this a primarily a developer exercise that you do in the beginning as a whole, or is it like on individual, let's say, you know, you have an issue or a set of issues you work with someone else to flesh this piece out to understand the model for the way the assignment service, or the assignment component works?
I'd say it's the latter. And you need to have consultation, I guess, would be the best interaction with your domain expert in that case. So you have the developers who are relevant, working on a particular topic, and they flesh out the model, and then they can communicate that information to the rest of the team.
Okay. That seems legitimate, right?
So it's a lot more manageable than doing it with 20 people in the room.
Yeah. But that's
so,
the issue, the reality that we have to face. All right, so let's say we do this. Let's go further. So what does this help us understand then about the model now that we have this use case?
It helps me to understand a little bit better what a teacher is. All of these properties that are on this teacher view model also belong on the teacher. So what does a teacher contain? It contains all of those things. I think that's really what this exercise has taught us.
And are you building a picture that goes across all of those layers that you talked about? Like, I think the layer that Gibbs is talking about is, I don't care what application we're dealing with, whether it's a native mobile app or a browser app, we're going to define a teacher the same way, and that's really important.
Mm-hmm.
So you can almost kind of put off is it being pulled by a native mobile app or browser app. We just need to really agree on what a teacher is or what an assignment is. But it seems like in this example, we're building the model at all 4 of those layers, right?
Yeah, and I think that, so perhaps this exercise is better for architecture on like a broader level, but maybe not so much for defining what our model is specifically. So I think that's a great distinction to make. Yeah, Prem?
Yeah, I feel like this, where you're saying you're trying to get here, you could have gotten there with the first diagram.
With the first diagram?
The first diagram you drew when you were going back and forth 1,000.
Yeah, so just that kind of conversation. And I think that's true. Like, you can get a long way that way as well. I think that perhaps Bob brings up a good point that this probably wasn't the best exercise for talking about how to build out a good model, but I think it is a good exercise for talking about how to build out good architecture on all of the layers.
So what do we need to do more to flesh out the model of Scholar? Like we talked about note-taking, but Scholar is obviously more complex than that. At what point do we need to talk about that soon. Someone needs to explain it to us. Katie, for example, has the model in her head and needs to sort of transmit that to the rest of us. So we need a session to do that.
So maybe a next step on this particular thing would just be to have Katie sit down with a couple of the devs and actually diagram this stuff out. Yeah. In more of the interaction that Allison and I had in that role play.
Can I offer a perspective, since we did this on Friday for about an hour, like the whole thing, and what it forced me to do was, instead of saying, all right, so this is a note-taking system, it's got 2 columns and a summary, after we had gotten to that diagram, which took 2 rounds, just like that, talking it through and then doing it all over again, Cameron started breaking it down into steps, and I had to be there for it to further refine my thought process.
Sure.